In this video, we're continuing topic 8.2, and we're going to look through example 4. It's basically teaching or helping us think through this strategy. And remember, it's noun, units, and time on how we would have to label a lot of free response problems or their final answer when they ask us to explain things. They tend to do that a lot. And remember that a lot of these things are summarized in this chart up here so that you can kind of see here's the structure of what the answer is, and then this is what it means on the left side. So let's take a look at a few of these. So we have this integral expression. It's definitely starting at some kind of a point or initial condition. It's going from 2 to 4, okay? So we know that the time ends at 4 seconds. This is actually representing position. So this is the position of the particle. And then the units, if I go back here and I read, I didn't read very well. The position of the particle moving on the x-axis in feet from the origin is given by x of t. The velocity, so it said feet from the origin right there. The velocity of the particle is in feet per second. The acceleration is given by a of t. For each of the following integral expressions given in the following table, interpret its meaning by filling in the missing noun, appropriate units, and or the correct time value on the interval. So position, they just told us. It told us right here in the problem that it's in feet from origin, because I got the actual position. Now notice in this one, my time changed. My time is now from 0 to 1. So t equals, so let me write that again. It's going to be from t equals 1 to t equals 4 seconds. And then it's the change in the position of the particle, meaning it's not going the entire position, but it's just what's the change, because I didn't have that initial condition there. And the position we know is measured in feet. All right, now we've got the crazy 1 over b minus a. Notice it's 1 over b minus a. Anytime we see that, we know that it's average something. But you'll notice I have the absolute value of velocity, and the absolute value of velocity represents the speed. So this is the average speed of particle. It's in feet per second. The time, again, is going to be your endpoints or your limits on your interval, which is from t equals 1 to t equals 4 seconds. All right, looking at this one here, I definitely have an initial position that I'm starting at, but notice it's kind of going backwards. It's going to 0, t equals 2. So really what we're looking at for time is whatever that upper limit is. So at t equals, or at time, t equals 2. And again, this is just, it's doing the same thing as the first one's doing. It's talking about the position of the particle. All right, this one here is just absolute value of velocity, but we know that not only does it represent the speed, but it represents the total distance we traveled. So total distance that the particle travels. All right, and then total distance, because it would be measured in feet. And then they're saying it's from t equals 1 to 4. And then finally, they're talking about it being average acceleration, because I have the 1 over b minus a thing going on. Acceleration, we know, would be measured in feet per second squared. And then again, the time is still from 0 to 1. So from t equals 1 to t equals 4 seconds.